let's start. Let's start with the panel. I'll do some questions for our great speakers before, and then we let people from the audience also make their questions. So I'm going to start with the mathematics of phenomenology. Oh, no. You have here an audience with astrophysicists that are trying to look for signals of intelligence, life in the universe. What do you give them? So when they get the signal, you say, guys, this is conscious. My axiom, my theory is coming and is telling you. What do you tell them?
So so first of all, thanks for the easy questions to start with. I think so. Realistically speaking, we have these things which are called, nowadays they're called C-tests of consciousness, which are really just tests for consciousness, and in most cases they're just derived from the human case, based on some general thoughts, or sometimes they're validated on cases where we know that people are conscious or not, and they're not really applicable to any other system right now. We struggle to apply them to infants, and that works a little bit, but even on the AI side, right now, these tests are just not applicable. So there's lots of work to be done, but my best guess or answer to your question would be that I think, if anything, then this line of research will perhaps get us somewhere, where we can say, well, if there's a signal from some sort of system, then maybe in 100 years there's a test that we could apply, maybe warranted by theories of consciousness, or maybe warranted by computational phenomenology, that somehow allows us to say with certainty that this system is conscious or could have the capability of consciousness.
Leonard, you want to add something?
So, what I think is that consciousness means a lot of different things. And I think that we have to sort of have a definition and see what that definition implies. So that's one of the things that we try to do. And so I think the idea of getting one universal definition that's going to work for every aspect, for humans, for machines, for animals, and then going way down. I actually am starting to be a little bit of a panpsychist, feeling that consciousness goes way down. But I think that the notion of consciousness then is very different than the notion of consciousness for humans and machines that might act like humans. So I think one would have a different definition, a different notion of consciousness going way down, but I think there are notions.
Even in humans, there are disagreements about what a definition of consciousness is, right? So even in the human case, which might be considered the easy case, is not so easy.
Yeah, so a big question that I have and grappling with is, okay, given whatever definition of consciousness you have, how do you test for consciousness? How can you tell if something's conscious? And so I have some ideas that, at least for humans and animals, maybe if they dream, there's a sort of sense of consciousness, that dreaming is creating in the mind all these kind of feelings and images without having the input from the outside world or interacting with the world. It's all being created up here. So dreaming, for me, is kind of a fundamental, at least for human consciousness, and I imagine it goes down to a certain extent. And that's why I've been asking some of the people here, the animals that you look at, do they dream?
We have an expert in sleep and dreams here, a neuroscientist. Maybe we can ask him later to comment.
Okay, well, if you want to,
Yes. Great. Okay, so now a question for the neuroscientist of the octopus, of the humans. So you look in the brain, there's no ideas. You don't find them. But you think you can find signatures of consciousness in neural correlates. You're looking for them in the octopus, and you were trying to make maps of correlations. What if you don't find them? What if you will never find them? What if the consciousness is not actually there, but it's actually in the gap, in what is not there?
I think it's very interesting. I think also what we're trying to find, those correlates, those maps, even when we do find them, we kind of have the burden to prove that what we found is consciousness, right? That it's not report, that it's not me thinking about something, and it's not me, performing some task, that it's me experiencing, right? I think that's the burden of even finding something. So when we don't find something, I'm happy, actually. I think this is progress, because we can start eliminating things. But I wonder what would then...
I mean, I think that one of the main things is that we're looking at two different brains, right? So we're not looking for a brain area, because consciousness doesn't sit in a brain area. We're looking to some sort of similar activity. Where would that activity be? I think, at least with the octopuses, we're sadly not even near the question. Right now, we're still at the moment of trying to figure out what connects to what. Right.
So my final question before I go to the audience goes to the quantum and the robots. So you're trying to integrate everything that you can integrate for the robot to become emotional. You think you need to integrate all the ideas. And it might not be possible to do it in the general relativity world. For once you said, we need much more energy. It's very difficult to put all these things together. How are we going to do it? When the time goes forward and you're dissipating energy, you need a lot of energy to do it. Can you do it with quantum computers?
Well, you want me to answer?
You first, and then you can...
Well, quantum computers, I keep forgetting what they are, but I did have long conversations with David Deutsch many years ago, and I've also asked people now, and it seems to be it hasn't changed much since then. There are certain problems that quantum computers are much better at solving than classical ones, but they're rather limited in the particular ones. I think the thing is, from my own perspective, you see, a quantum computer is something which follows the Schrödinger equation, if you like, and then you do what's called making a measurement or something only at the end. So you're not really taking advantage of what I claim is an essential ingredient for what actually is involved in consciousness. So I'm trying to claim, people often say, oh, it's a crazy idea that quantum mechanics could be involved in consciousness. It's much crazier than that. You see, it's not, my point of view is not that it's quantum mechanics, it's that where quantum mechanics goes wrong or is not complete. See, the serious argument is that it involves what's actually going on in the collapse of the wave function, which is not current quantum mechanics, it's some theory beyond that which we don't have. Now, you see, if you're going to make a conscious quantum computer, whatever it's supposed to be, it would, according to me, be something which takes advantage of that going beyond quantum mechanics. And just that would only take part if there's something like a measurement, sort of, but more subtle than that, taking place within the process of the action of the machine and not just at the end. Just at the end, all you're going to get is probabilities. That's no use at all. If you want to take advantage of what subtleties are going on, as I claim, in the theory which would be beyond quantum mechanics, which is involved in the collapse of the wave function, which is, I claim, to be organized in some very subtle way in actual consciousness. I have no idea what it is. It's way beyond our current understanding. But this would have to be there, and it's not in what we currently call a quantum computer.
Yes, I wouldn't dare to say differently.
You wouldn't make your quantum robot.
But it depends on, I'm not very familiar with quantum computing. It depends on what part of the whole system needs to be quantum computing, because robots are very deterministic beings, and they must be very deterministic being for our own safety at the very least. So many of those things, things related to robots, I don't think can be implemented with quantum computing. Maybe the final, let's say, computational, integrated computational unit, it might be, but all the rest, possibly, we are going to use, I think, like deterministic.
Safe.
Yes, yes.
Ethics maybe needs it. Okay. So, questions from the audience.
Hello. Thank you very much, all of you, for your wonderful talks. So my question has to do with, so I work in collective intelligence and I'm very interested in emergence. And I wanted to ask, what are your thoughts or opinions on the emergence of consciousness and that of life? I've noticed there was repeated mentions in your different talks about the process-like aspects of things, how process is incredibly important, that there is dynamics, that there is constantly change. And a lot of theories of emergence are based on various processes of multiple components working together at a balance between chaos and order, or integration and segregation, or individualism and cooperation, all of these different levels. So I would love to hear your thoughts and opinions about whether you think consciousness is emergence and you think that it's processes that is the most important, or something else. Same with life. I think that question applies to life as well. Thank you.
Lena.
Yeah. So emergent is a kind of funny thing. It's almost a little like magic. You like to think of it emerging. I think emergence needs explanation. So, for example, in our model, consciousness develops, evolves, and it gets, it has to evolve. And I think that happens also. So I wouldn't say emergence. So, emergence is sort of like going from one state to another, I think, is what people mean by emergence. And I think that needs that's an explanation. It has a gap. And I think people use emergence to have, when it gets complex enough, you'll have consciousness. And I think that's a way of trying to dissolve the problem. So I have a problem with emergence myself.
You want to say something?
Yeah, if I can add something small, but this is actually a discussion that goes back to Ronnie, so I thought maybe she wanted to too. But I think so fundamentally, emergence is well understood in certain contexts, but these are not the contexts of life and consciousness. And I think to a large extent, emergence is now a buzzword that hides non-understood things. And I don't mean, like, it doesn't hide a reductive understanding, but it hides the fact that we need to develop better mathematics to really account for what could be happening in that realm. And we can't just hide it under the blanket of emergence. And there's wonderful work in consciousness science, or adjacent to this, by Fernando Rosas and Pedro Mediano and others, and Eric Hoel. And they're trying to construct these models of what concrete thing we could actually be meaning. I don't know if Ronnie wanted to top that up.
Yeah, if I can just make the attack more, put some butter on the knives. I think that, like Johannes said, there are people in the field that are working on emergence, and the reason is that it's very on point and interesting in terms of this complexity and integration and this sort of trade-off between chaos and order. And it has been there. You see it in theories, in different theories of consciousness over the years. You also see it in measures of complexity that we relate to consciousness and then apply, for example, in tests for people with disorders of consciousness and trying to perturb them and see basically if their brains react in a complex enough way such that we would expect them to regain consciousness. So I think it's always been there in the background, but I think as is in the sense of the idea, like Lenore said, as a theory of consciousness, or as something that is singularly, like, explains consciousness in some sense, I think that there it's kind of trying to just take a hammer and apply it on the field. We should be careful of that. We can take those ideas of complexity and of emergence and of free energy and things like that and see how we can apply them in consciousness research. I don't think that they alone explain consciousness. I don't know about life, but yeah.
So thank you all for the wonderful talks. I have, I noticed that for like 20 years there's been a lot of progress on functional aspects related to consciousness in neuroscience, etc. For instance, in the conscious Turing machine, we have a very elegant mathematization of some aspects of what comes from the global neural workspace theory. And at some point, it looks like if you have two things which are functionally equivalent, they will be equally equal in terms of conscience. Now, my question is, and this is a sort of an amusing provocation for Lenore and Johannes, if you make a digital implementation of the conscious Turing machine on a classical digital computer, according to which Johannes' theorem says it cannot be conscious, how do you sort it out? So is the substrate relevant or not? And if it is relevant, does it have to do with the quantum reality that Sir Roger Penrose is alluding to, which I think is a very serious possibility, but somehow it's very hard to grab. I've heard it mentioned in Roger's talk and by Sonia in the morning, and never again. I'm very surprised. So please comment on this.
Yeah. So when I was listening to Johannes' talk, he gave a way out. He talked about a mortal computation, and of course our conscious Turing machine has a finite lifetime, so maybe it falls under that, but I'm not sure. So we've been, Johannes and I and his other colleague have been talking about this and sort of trying to sort of work out what's going on really, because in fact, the way I see it is our brain really models very much like what he was talking about earlier, because we have evolution that's really tested all our neurons and our connections and all of that. So I think that what the hypothesis for his, so he has two theorems there, one talking about non-consciousness and the other one consciousness, right? Mortal is conscious. If it's not mortal, it's unconscious. It's not conscious. But I think the same applies a lot to the human brain, that it's actually been verified in many ways, verified by evolution, quite frankly. So I think his theorems, both theorems apply to the human brain, both mortal and non-mortal. So,
yeah, congratulations, Klaus Peter. You found the exact spot that we're discussing right now. And I think that's a good sign. And I really think that this is the sort of way progress happens, real progress. That we have opposing perspectives that come together. I'm convinced that Lenore's model is both a mortal computation and dynamically relevant, so it escapes both theorems. But we have to find out in which sense exactly, and that's the discussion where that's currently happening, yeah. Kudos, yeah, seeing precisely through, yeah.
Yeah, as we get some solutions, we'll keep you informed.
Yeah.
Back here.
There's a question on it.
Yep.
No. Hi, thank you so much for your talks and the opportunity to ask a question. I originally wanted to ask how quantum computing fits into the mathematical consciousness science paradigm. But now I specifically want to ask if you think that quantum computing in its not binary representation of information, if you think it has the potential to simulate or model the chemical communication of neurons, and also if you think it's reasonable to compare that chemical transmission or neurotransmitter communication as a not binary form of information versus electrical signaling and as a binary computation.
Well, my own view, as I was saying before, is that quantum computing is not to do with consciousness. I mean, within my limited point of view, whatever is involved in consciousness would involve in something, physical theory, to explain it, would have to be something which goes beyond current quantum mechanics. Now, current quantum computing, the notion of a quantum computer, as I understand it, and as David Deutsch tried to explain to me many, many years ago, you evolve the system according to the Schrödinger equation, basically, and then only at the end do you do what's called making a measurement. Now, my view is that whatever is involved in making a measurement, or the collapse of the wave function, has to be crucial to what's involved in consciousness. We have to have a theory of what the collapse of the wave function is, what's really going on there. And the way we treat it, it's only just randomness. You get a random answer, a certain probability of A and certain probability of B and a certain probability of C, something like that. But that's all you get out of a quantum computer. Now, there are certain problems. I've not studied the subject, I have certainly not recently, but there are certain class of problems which you can solve more quickly with a quantum computer. I think there's a thing called Shor's algorithm, which was the first one that was, you could speed it up using a quantum computer. That was the idea of it, I think. But that's a very limited class of problems, and in my view, it's not what's involved in consciousness. So it doesn't get us anywhere if we're trying to understand consciousness. It may be that they're useful in certain classes of problems. It's quite possible. It may be that a development beyond what we call a quantum computer could be more useful, where what's going on in the collapse of the wave function takes place as part of the process of the machine. See, that's not what's involved in what we mean by a quantum computer now. See, it's only right at the very end do you sort of measure what the state is, which really means you're involving the collapse of the wave function. It's unitary evolution all the way right to that point. That doesn't do you much good. Well, it may do some good in this limited class of problems. There is a class of problems, as I say, involving this thing called the Shor algorithm and developments from it, which can be more quickly solved using a quantum computer of that type. But it's not solving non-computable problems or something like that. It's not addressing the issue of consciousness according to my point of view. Of course, my point of view might be wrong, and in that case, it's got a chance, but that's giving you my point of view.
Maybe I add something to this. There are some quantum physicists, Natalia Aras here, for example, in Oxford, that is trying to get clever artificial neural networks to learn from quantum systems are entangled and then they're not entangled and collapse and don't collapse and recollapse. How learning of the neural network takes place and in which moment you can extract something that is not classical information from a quantum system. And also many of us are starting to understand or to design experimental systems very much based on this, trying to really figure out is there quantum effects working in biology, what is called quantum biology, not only in simple computation like photosynthesis, but in more complex computations like it might happen in the pyramidal neurons that Roger was saying before. So yeah, quantum biology maybe matters. Okay. Here.
Yeah, so I want to get back to collapse of wave functions. For a long time, I've been bothered by the role of observers in collapse of wave functions. We always talk about how an observation is what causes a wave function to collapse. But what is an observation in a universe or a part of the universe without life and conscious observers? Do wave functions just never collapse? And for that matter, if you built an AI that did an unsupervised observation, would that cause a wave function to collapse? And so what is an observer? Can bacteria be observers? Can AI be observers?
This is what these experiments I was trying to say are trying to do, but maybe someone else wants to give
Yes, may I comment on that? You see, I think it's completely misleading. I mean, the terminology is misleading because people say making an observation is what collapses the wave function. That's a point of view which was very much promoted by Wigner. I used to have discussions with Wigner about this very question, and I found he was not so dogmatic as one tends to think. But he said it is a point of view, that is somehow the observer comes along, observes the quantum system, and that collapses the wave function. That's certainly not my view. It's nothing to do with a conscious observer coming along looking at the quantum system. Well, something to do with it indirectly, but nothing directly to do with it. I mean, if it needed a conscious observer, then you would have, see, there would be planets out there where the atmosphere was a mixture of all sorts of different weathers at the same time. Not a mixture, a quantum superposition of all different weathers. And if there's no conscious being anywhere close to that planet, it wouldn't collapse the wave function. And so you'd have things going on in the universe which are not anything like the classical world that we see. And, I mean, you can argue about this. I just think it doesn't make any sense. It's not a conscious observer coming and looking at the system, despite the terminology which sort of talks about observer somehow. It's nothing to do with that. Well, not directly to do with that, I should put it like that. It's the system collapses itself spontaneously when the superpositions become too big. And that's, of course, it's not, there's no universally accepted view of this. I'm giving you my view. But my view, and I think it's better than the view somehow that conscious being collapses the... It's better because that view leads you to... The sort of example I think of is you have a distant planet. There's no conscious observers anywhere close to it, no insects, no butterflies, no nothing, no life of any sort. The atmosphere on that planet is a complete superposition of different atmospheres. Okay, you have a space probe goes out to take a photograph of that planet. It takes a photo, there's nobody on it, this probe. It takes a photograph many light years away, takes years and years and years. It comes back, and it finally gets close enough to the Earth to send a signal, and somebody on the Earth sitting at a screen suddenly looks at that atmosphere, the first time a conscious being has had anything to do with that superposition, and bam, way back into the past or whatever you like, I don't know, this atmosphere has become one atmosphere, not a superposition of different atmospheres. To me, that's a nonsense. It's already collapsed. It's nothing to do with a conscious being there at all. Of course, you can take that view, and you can take the view if you like. It's just, I think it's an absurd view. That the conscious, only when the conscious person looking at the screen, seeing this nonsense of superposed atmospheres or all that, clouds all over, superposed, smeared all over the planet, and suddenly, whomp, they go one particular atmosphere. Makes no sense to me. If you want to support that view, you can, but I don't think it gets you very far. Sorry.
Quickly, yeah. So I just wanted to add something real quick. I think what the question really aims at is the question of what's the role of consciousness in the universe and in fundamental physics. And I think we're at a crossroads, and there's two possibilities. Either we find out consciousness is some specific brain function, and then we understand that, and it's going to have a huge amount of societal applications, but that's that. And the other possibility is that we find out that we have to seriously revise our understanding of the reality, the way we look at reality, at the universe, because of consciousness. And these are two options that are, at the present stage, at a point of time, both possible. We don't know which ones. And I think the crucial work is trying to work on each side very rigorously to understand what that would mean and how we could find out empirically.
Great. So on this, I see our new Chancellor, William Hague, has arrived. So I think we need to finish and thank all the speakers for all their wonderful ideas.
Yeah.